Lesson 3.3 is titled Polynomial and Synthetic Division. In this lesson, we'll look at long division and synthetic division as a way to determine if we have a factor and finding zeros. We'll also look at what's called the remainder and factor theorem. It says consider the graph f of x equals 6x to the third minus 19x squared plus 16x minus 4. So go ahead and make that change to minus 4. That's the graph over here on the right. Now it says, notice one of the zeros is. So as I look at this graph, I can tell it's divided by 2's, and I see pretty easily that there's a 0 at x equals 2. That means that's where it crosses the x-axis. That also means that x minus 2 is called a factor of that polynomial. And there would be a second-degree polynomial q of x such that f of x would equal x minus 2 times q of x. Q of x is known as the quotient, or the answer you would get after you divide out, except I spelled that wrong. Forgot the E. That would be the quotient you would get after dividing out x minus 2 on the other side. So if we do that division, that means we're going to divide our original polynomial by x minus 2. So let's show that first using long division. And if you remember this is kind of a long process. We'll take our factor x minus 2 and place it on the outside. We'll draw a really long kind of division bar, and we put our polynomial 6x cubed minus 19x squared plus 16x minus 4 on the inside. To do long division, your process is to look at the first term on the outside and the first term on the inside. What could we multiply x by to cross off 6x cubed? Well, we would multiply it by a 6, and we would also need an x squared. So what I'll do with that is I'll distribute it to that x, and that gives me 6x cubed. I'm going to line it up with that first term. We also need to multiply it to that second term. 6x squared times negative 2 becomes negative 12x squared. Now to eliminate terms in the polynomial, what we're going to do is subtract this row. And when we subtract, we need to change both the signs. So the 6x cubed becomes negative, but the negative 12x squared would become positive. That allows you to cancel out your first term and then see what you have left over. Negative 19x squared plus 12x squared would be negative 7x squared. And then you drop down your second term and do the process all over again. Take that first term on the outside of x, and now the first term with what's left over is negative 7x squared. What could we multiply x by to equal and cancel out negative 7x squared? We would need negative 7 and x. Again, I'm going to multiply it by that first term, and that would give me negative 7x squared. Now if I multiply negative 7x times negative 2, we actually get positive 14x. But when I subtract out this row, that changes my negative 7x to positive and positive 14x to negative. Canceling out that first term, and then we see what's left over. 16x minus 14x would be positive 2x. One more round, because we still have our constant, we'll drop down that negative 4. And now we have x on the outside, and we have 2x that we want to match it with. That means we'll multiply it by 2. Distribute it to the term first with x, that gives us 2x. Distribute 2 times negative 2 to that second term, that gives us minus 4. Now when we subtract each term out, that becomes negative for 2x and positive for 4. Everything actually cancels, and we get a remainder of 0. That means x minus 2 goes into the polynomial evenly, and our quotient, q of x, is just the part that's left over. 6x squared minus 7x plus 2. For some instances, when we do division, terms are going to be missing in our original polynomial. It says divide x cubed minus 1 by x minus 1. Notice there are a bunch of terms missing from the cubic term to the constant. So as we write that out inside the division bar, we need to include those terms with a coefficient of 0. So here's what I mean. Our factor is what we're dividing by. That goes on the outside, x minus 1. We'll do a long division bar because we're going to put a few things in here. The first term we have is x cubed, and technically that coefficient would be 1. But then we're missing an x squared term. That's not in that original polynomial. That means 0 is its placeholder, which will be significant when we try to determine our quotient. Notice we're also missing the x term. That means we need another 0. And then negative 1 is our constant. Once you have all your terms from biggest exponent down to constant, then we can do our division. Let's take the first term on the outside, the first term on the inside. What could we multiply x by to equal x cubed? This one isn't too bad. We'll just multiply it by x squared. Distribute it to both of those. X times x squared would be x cubed. And then x squared times negative 1 would be minus x squared. As we do that subtraction, the first term becomes negative, the second term becomes positive, and that first term cancels out. So if we have 0x squared plus x squared, technically that's plus 1x squared. So that would give us x squared left over. And then we drop down the next term, which seems weird still because it's 0x. Start your multiplication process. How do we make plain x look like x squared? We'll multiply it by x. Distribute it to both parts. X times x gives you that x squared again. X times negative 1 gives you negative 1x. I guess we could put a 1 up there too. When we subtract, minus plus, and that first term cancels. The second term, or the second column, we have 0x plus 1x, meaning we have 1x left over, minus 1. And now notice that x will go into itself one time. And when we distribute it to both parts, we get x minus 1. And when we subtract, not only will the x's cancel out, but the 1's will cancel out. We get a remainder of 0. That means our quotient is just the part on top, x squared plus x plus 1. Now, not everything has a perfect factor. Sometimes you'll have a number at the bottom left over, and that's known as the remainder. We definitely saved the best for last with this one. It says divide negative 5x squared minus 2 plus 3x plus 2x to the fourth plus 4x cubed by 2x minus 3 plus x squared. You've got to be kidding. All right, let's take a look at this. The first thing you would want to do is write everything in order from biggest exponent down to constant, just to make sure none of your terms are missing. In the big polynomial, I notice that 2x to the fourth is the highest exponent, and then 4x to the third would be the next one. The negative 5x squared just means it's subtraction. And then there's plus 3x, and then there's minus 2. So this would be a quartic function, and notice all terms are present, so we don't have to have any zeros for our coefficients. So we're dividing by 2x minus 3 plus x squared. I would write x squared first. 2x is positive, and the constant is negative 3. Whew, we need a lot of space for this one. Whatever we're dividing by goes on the outside. So that's x squared plus 2x minus 3. And then draw a really big division bar. And let's get all of that polynomial to fit on the inside. 2x to the fourth plus 4x cubed minus 5x squared plus 3x minus 2. All right, so now what we need to do is take a look at the first term on the outside and the first term on the inside. What could we multiply x squared by to equal 2x to the fourth? Well, we'd need a 2 for sure. To get x squared to equal x to the fourth, we'd have to multiply it by another x squared. So I'm going to write that as 2 times x to the second, or 2x squared. Now we distribute it to the first term, and that gives us 2 times x to the fourth. We distribute it to the second term, and that gives us plus 4 times x to the third, and we distribute it to the third term. 2x squared times negative 3 becomes negative 6x squared. All right, draw your line. Let's see what we get here. Change all your signs. So we get a minus, and then a plus. Notice the 2x to the fourths cancel and the 4x to the thirds cancel. So at least we have less to work with. All right, let's see what's left over. Negative 5x squared plus 6x squared would be 1x squared. And now because there's more terms on the outside, we have to drop down more terms on the inside, just so that we have a matching amount. All right, it looks like this isn't going to be so bad. Now we have x squared and x squared. So I would just multiply that by 1, which means we have to multiply everything by 1. And that gives us x squared plus 2x minus 3. When we subtract, change your sign, change your sign, change your sign. The x squareds cancel, but we have 3x minus 2x left over, which is just 1x, and negative 2 plus 3, which is plus 1. Notice x squared does not go into x evenly, so it does not divide. That means that x plus 1 is our remainder. Maybe you guys remember the remainder rule back in Algebra 1 and Algebra 2. So this part right here is our remainder. That means to write out our quotient, q of x, we'll start off with the stuff on the top, the 2x squared plus 1. And then to write the remainder, we just put plus, we put whatever the remainder is, x plus 1, over whatever our dividing factor was, x squared plus 2x minus 3. It's a pretty big quotient to write out. And that's it for the first part of 3.3. We'll change it up and do synthetic division in class.